Hey everybody, I'm just getting things set up so that we can start our next video. Here we go. We've been working our way through Unit 3, which involves chapters 8 and 9, where we're looking at the systems of equations. And today we're looking at section 9.3, where we talk about quadratic inequalities in two variables. And notice that that's different from our last lesson, which was one. So now it's back to the two variables. So we'll be looking for solution regions now. So, the objective of what we need to accomplish is to make sure that you're comfortable with sketching and solving problems involving quadratic inequalities. Vocabulary terms, now these are things you've seen before, but I just wanted to remind you of them because they will be appropriate for what we're talking about in this lesson. Test points, still, solution region, and boundary line. Now, before we start, I just thought I'd point this out to you because it's kind of an interesting fact about the parabola. It says one of the common styles that designers use for doorways or windows are arches. And of course, you're very familiar with that. Wherever you go, whether it's in an old historic building or whether it's in something that's newer, you'll often see beautiful archways in the architecture of things that have been designed. And the interesting thing about this is that the parabolic arch is the strongest possible arch because it is self supporting. And what happens is the shape of the arch in a true parabola causes the force of gravity to hold the arch together instead of pulling it apart. And I just thought that was such a cool fact about the real world in terms of parabola being so strong and it supports itself. And that's why we see it in all kinds of architectural designs, and also engineers use it. And that's part of the reason that we are going to be taking a look at this too. So, to make sure that the arch is functional, the designer, whether that's an architect or an engineer, can set up and solve a quadratic inequality in two variables. And that kind of gives them some information to help them determine whether or not the arch is functional. Okay, so let's go to the math. What is a quadratic inequality in two variables? What are we talking about? Well, my hunch is that you probably have enough information and background to be able to answer this just by your intuition or common sense. So let's give it a try and see what happens. If I said to you, could you show me where the solution region is for where y is less than x squared minus 2x minus 3? So I would want you to kind of begin to look at that and think about, well, how might I actually find a solution to this one? What would I actually do? Pardon me. Sorry. That was a sneeze for you. Hopefully, I won't start sneezing. If I do, I'll have to cancel the video and start again. But just keep in mind that right now we are looking for x and y values. So that means we're looking for all the different points that make up a region. So we're now looking at shading once again, rather than just the values of x that we had in the last lesson. Okay, so sure enough, the first thing that you're going to need to do is to create a graph of some kind. Now, I use Desmos to do this, but you could have also graphed this on your own if you think about it. You could have easily factored to find the two zeros being -1 and 3. You could have moved things around or used your formulas to figure out where your vertex actually is. But you create in either direction, you create this nice graph. So now there are a couple things we need to ask ourselves. What region of the graph of the function, so this function that we have, our parabola, is less than the quadratic? So where are the y values less than that? And secondly, what kind of boundary line is appropriate for this one? Well, if we look back, we see that there is no equal sign. So when we go to draw our final answer, we really should use a dotted line to indicate that it's not equal. And if we think about where are all the y values smaller than the quadratic, well, they're going to be smaller underneath. And so the region that we're going to need to shade is outside almost our quadratic. And so if you thought about it and you think, okay, well, I think the region is outside, what could we do to test our answer? Well, let's try a point. Now, the easiest point I find is 0, 0, just because it makes for an easy, fast answer. Now, if I'm right, then 0, 0 should not work. So let's check it out. If I put a 0 here, I would get 0 is less than, this would be 0, 0. -3. Well, 0 is definitely not less than -3. So that point, 0, 0, is definitely not in the solution region. So sure enough, my solution region would be the outside. And please notice as well that we've used the dotted line to indicate that it was not equal to. Right? So this is very much like the linear inequalities that you just did as a review not too long ago, except all that we're doing is using the quadratic instead. All right, so let's just do a few more. So if you remember the objective of what we had in this lesson, we were going to make sure that you knew how to sketch these things and then to use them to solve scenarios or situations. So if you look at this guy and you're asked to graph it, I think most of us would see this and think, okay, sure, I can get the vertex pretty easily. It would be 3 and 1. I can see that it's going to open down because it's negative. And so I should be able to draw for myself a graph of some kind. You'll notice as well that I jumped in and used just a dotted line because there's no equal sign there. And so I have a graph that looks something like the following. Now I need to describe or decide where are the y values less than the quadratic. So where are the y values going to be smaller than the quadratic? Well, it would appear that I might need to test some answers to be able to check. So why don't I try 0, 0? If I'm thinking that it's in here, that it's less than, then 0, 0 should not work. Let's try it. So I put in a 0, and then I put in a 0 here. And what I'm getting is 0 is less than -17. Definitely not true. So 0, 0 is not in the solution region. It's looking like it should be the inside. So let me try another point, 3 and -3, which is definitely inside. If I put those numbers in place, I'll get -3 is less than 1, which sounds exactly right. So that leads me to conclude that my solution region is on the inside. Now, there was a second part to this question, and it said, is the point 2, -4 a solution? So we look, 2, -4. Sure enough, it appears that it's plopping into this solution region. So according to the graph, it should be fine. But let's double check it as well. And let's put in this point. And so for x is a 2 and y is a -4, I plug it in and go ahead and solve my numbers. I find that -4 is less than -1, which is true. And so sure enough, this is in the solution region. Okay, another one. Let's graph the following. This time we're showing that it's greater than or equal to the following function. So we create a drawing. We use our zeros to help us know where it crosses the x-axis. We could also find our vertex by using our formulas, or I could turn it around into vertex form if I was feeling energetic about it. Now I need to show that it's equal, so I've got a solid line. And I want to show that the y values are greater than this one, so that seems to be inside. Let me double check and see if I have some answers. Let's use 0, 0. Looks like it should be the right one. Plop in a 0. 0 is greater than or equal to -5. Sure enough, that is true. And so our solution region is on the inside of our graph. Okay, so to finish off, we'll try a real life application and then you'll get a chance to practice a few more when you do your homework. So, what we're going to be looking at are parabolic reflectors. Now, this one looks to be a reflector for light. I suspect it's something that they're using kind of in filming. They're using a light and they're reflecting it to create this great wash of light underneath them. You can also have some for sound recordings as well. And so these are called parabolic microphones. And they have a parabolic reflector attached that directs the sounds to the microphone. So take a second look at this diagram. You can see, of course, that this is your parabolic shape, this plastic kind of disc. And then the sounds are collected inside and then directed towards the microphone. It's a very high tech form of recording. So let's take a look. Rene, a journalist, is using a parabolic microphone as he covers the Francophone Summer Festival of Vancouver. Describe the region that Rene can cover with his microphone if the reflector has a width of 50 centimeters and a maximum depth of 15 centimeters. So we're supposed to describe the region. That's a little bit abstract in some ways, but one of the most concrete things we could start with is to try and draw a quick sketch of what we're being told. If we think about a cross section of this reflector, we're going to have like a parabolic surface that goes like this, and it has a width from here to here of 50 and a maximum depth of 15. Now I'm going to create a drawing of that one, and I'll put it on a coordinate plane. So I get from here to here is 50, and from here to here is 15. That gives me the ability, by putting 0, 0 at the vertex, it gives me the ability to actually name the vertices on the edges. Sorry, not the vertices, but these points on the other side. So what I'd like to do is to create a quadratic function that describes this guy. So now he's passing through 0, 0. So that means y is equal to ax squared would be the typical equation that I use for this one. And since I'm going through the point 25 and 15, let's do the math and see if we can figure out what a would be. Okay, so if we have this one and we know it goes through this, let's plunk in those numbers. X is 25, y is 15. All right, let's get a by itself. Now, if I were to take those numbers and try and simplify them a little bit, I should find that I can divide by a 5 on the top and the bottom. And so 3 over 125 looks like it's what a is equal to. So now we should be able to go back and put that in our equation. So the following should describe this quadratic that I see in front of me. Y is equal to 3 over 125 x squared. So now if we're going to describe the region that Renee can cover, so think about what he's doing here. The sounds are coming in, they're bouncing, and they're going to a microphone here. So basically, the region I want to describe is this part in the center. So I want to say that y is greater than or equal to the following equation. It's the inside of this particular quadratic. Okay, there you have it. You've done a little bit of practicing of sketching and solving problems. You'll get some more practice when you try the following questions. Please notice I'm trying to make the instructions a little bit specific. Numbers 1 and 2, I only want you to do the odds only. 4, 5, and 6, please choose 2 from inside to try. Do all of 3, 8, 9, and 12. And if you do those, I think it should give you a really good basis on understanding the kinds of things that you need to be able to do with this particular information that you have. All right, so remember that if you have any questions, you can always put it in your homework check-in, and we'll check in later and talk about it whenever you have troubles. So good luck, everybody. Take care.